Hi everyone, this is mechanics chapter, and today we're going to do a past paper question. That is a mechanic questions. It's a resisted projectile motion. Okay, so this is the 2013 HSC Extension 2 question 15 D. A ball of mass m is projected vertically into the air from the ground with initial velocity u, and after reaching the maximum height h, it falls back to the ground. While in the air, the ball experiences a resistive force kV squared, where v is the velocity of the ball and k is a constant. The equation of motion when the ball falls can be written as mv dot equals mg minus kv square. Do not prove this. Excellent. And then there's a 3 parts, guys. Yep. So 3 parts. I'll just let you read. But when you have something like this, please underline important information so that it's easier when you start doing the question. So let's have a look. I'm just going to leave that one for a second. So first one is to show that the terminal velocity Vt of the ball when it falls, okay, so when it falls is the square root of mg over k. Okay, so let's have a look at that. So that's when we know the terminal velocity, the v dash equals 0. Okay, now which is acceleration is 0. Okay, so we're using the formula, and I'm going to change the v is a vt because that's the terminal velocity, and we just have to make the vt the subject as required. Okay, now we're going to pick the positive here because the falling is positive there. All right, so that wasn't too bad. Second one is to show that when the ball goes up, the maximum height h is the, I'm just going to put that in there. That's what we have to prove. Okay, so we got this. If you think about it, that's a big capital H there. That's a U there. VT there. So something that we haven't got, we have to use here. So what does that mean? Is this there's a limits in there. See, it limits for the height. We were going from the nothing to all the way to the h. And the velocity will be from initial velocity will be u, but then it'll reach to the maximum height, right, when it goes to 0. So that's what we're going to do. So we start with the formula that we were given. Now this time going up is positive, so the whatever it's going down has to be negative. Okay, and then that's a resistance, so it's negative. So I'm going to change that to v dv dx equals minus mg minus kv square, and I'm just going to divide it by m on that side, and then we are going to swap this, the whole thing. Okay, and when I do that, I'll get this. Now this we need to make it into smooth integration form. So I need, what do I need? 2 kV here on the top. So I put 2 kV, take the m out, divided by 2k, so that it won't change the original expression. And then we're ready to do the integration. Now this is the part, have to be very careful about limits. So the displacement obviously have to deal with the 0 and capital H, but the velocity need the little u and reaches to 0. Doesn't really show dark enough. Hopefully you can read it carefully on that. Oh, I think I know I can do better. This will do 0 u 0 U. Excellent, that's better. Okay, so I'm going to take that out. Obviously, that's ln. And this one is like h minus 0, so it doesn't really matter. So it's going to be h. So now I'll put 0 there into v, and then I put u square there for when it was a v. Okay, so that becomes like this, isn't it? Because it's ln. And I'm going to take minus 2 on the top. Then it'll flip, you know, that becomes minus 1, and it just flips around. Why? It's just easier for me to separate into 2 terms. Okay, so that way, because in the show proof part, there was 2 parts in there, so I need to do whatever I'm supposed to be doing. So I've done that, but it still doesn't look like what we have to prove. So let's have a look. We need to have a VT square somewhere, isn't it? Because it doesn't show it. So from part 1, we had a VT square equals mg over k. So I'm going to use that, and I'm going to times the g on the top and the bottom. Okay, so when I do that, so top and the bottom here, I'll get this. And I'm going to separate the mg over k times 1 over 2g, because that I can change into vt square. And then I can use this as a vt square over 2g. Then I will have vt squared, right? And I'll have a g and everything. So still from here, and also I want to change this in terms of mg here. So I'm going to use this to substitute it in. Now, if you don't understand this part, just watch this a couple of more times and you will understand. Okay, so when we do that, when we put it back into this 2 into here, we'll get this. Okay, so be careful, take your time and put it back in. So when you put it back in, and you will get the way we were supposed to prove. All right, so that wasn't too bad, but it was still a bit confusing. The next one, last part, show that is then. Okay, so it's this time is when the ball falls, so it's going down is a positive, and our goal is to find the equation in terms of W. Okay, so it's very similar to second part. So I'm going to start with using the equation, and then we'll get this. All right, and I'm just going to divide it by m, and I will get that, and I'll swap this together. It's because I need to simplify by integrating. Now that's what I've got here, and I have to use limits again here. Now this time limit is everything is fall on the ground, so it's going to be highest to the 0, and then I'm going to speed to the 0. So just be careful with that. So I'm going to integrate there, and my integration is 0, h to 0, and then w to 0. Okay, so that becomes minus h because it's a 0 minus h, and then I will go minus m to k and ln mg minus kv squared. Now when I put the 0 there and then w, actually what I've done is I just changed the negative so that it would be w and 0 instead of 0 w. So I don't like the negative there, but this one still has negative. Okay, so when I do that, I can put the w into the v, 0 into the v. So that's what I've got. That's not too bad. And I just tied it up a bit, and that's what I've got. All right, so and then what happens next? From 2, we got no, hang on a minute before we do that. Yes, from 2 we had this and changed everything in terms of vt square and then 2g and all other things. So I'm going to use that and changing in terms of all that VT squared, because that's what we got to show, to prove. So I've got that, and then this is for the H in terms of the going down distance. Okay, going down distance. Now, obviously going up and going down is the same because they hit the same height, the highest maximum height, all right? So going up, going down will be the same distance. So I'm going to equate the two heights, okay? So from part 2, I'm going to make it into equal to this one. So that's the part 2 equation there, and this is what we got here. I'm going to make that equal. And then I'm going to change this negative part, and I'm going to swap. Yeah, because I moved that one to there, and I just flipped. And then cancel this out, and then cancel that. So I've got this to left. And I'm going to make that into the 1 fraction, and then cross multiply. Okay, so when I do that, I'll get that. And I expand this one, and I'll cancel this out. And I want it to be w squared to be my subject, because it says here 1 over w squared equals something. So I know I want the w squared to be my subject. So I want to put w squared into my left hand side. I want to make that the subject, and I'll get that. And I will have w squared equals this. But the question says prove that 1 over w squared. So I'm going to just flip this one. And then I'm going to separate these to 2 fractions. Okay, when I do that, surprisingly, that would be what I should have. Okay, because I'll cancel this out. So I'll have 1 over u squared, and I'll cancel this out. It will be plus 1 over vt squared as required. Isn't that wonderful that everything works out really nicely? So that's HSC 2013 HSC Extension 2 question 15D. Okay, well done people.